Wind is moving air. Though we cannot see it, we can see its effect. We can see its effect through trees, flags, grass, clothes on the cloth lines. How is wind created? It is caused by uneven heating of the Earth's surface by the sun. Due to this heating, warm light air will always rise, while on the other hand, cold air will always fall. Since many years ago, people have harnessed wind energy. The Egyptians used wind to sail ships on the Nile River. Later, people created windmills, which were later improved to do various activities, as we can see in this picture. These activities included grinding maize, corn, pumping water, and cutting wood. Later after, they generated electric energy from wind. Now, let's look at the relationship between wind and air pressure. This guy was to move from point A to B, and at point B, he is to carry a bag back to point A. Considering this scenario, in which direction will he feel a lot of pressure? Practically, from point A to B, there is low pressure compared to point B to A, where he is carrying a bag. This is because of additional weight from point B to A. This cost him a reduction of speed to increase the body potential to carry more weight. Now let's apply this in wind scenario. We have learned that increased pressure will cause reduction in speed. We'll have another experiment where we will try to blow air on a paper as illustrated in the video. In this experiment, we realized that the paper will move upward since air will always move from high pressure to low pressure. Hence, the paper will move upward. Here we come into conclusion that air will always move from a point of high pressure to a point of low pressure. In this movement of air from high to low pressure, this is whereby now the air from high pressure will push the paper upward to the point of low pressure, hence the paper will remain straight. Now let's look now at the movement of air. As we have seen that air will always come from high pressure to low pressure. For instance, if point X is of high pressure and Y is a point of low air pressure, air will always move from X to Y, meaning that pressure difference causes air movement. Now, how does the speed of wind increases or decreases? The more the air pressure difference, the faster the moving wind, and vice versa is true. To summarize this, or rather to file this in a single file, we discussed that we realized that high speed wind are accompanied by reduced air pressure, and air moves from high air pressure to low air pressure region. This is a clear impression that Wind speed and air pressure are always meshed or rather twinned. Meteorologists discovered that it is important to measure different aspects of wind. Different aspects of wind that we can able to measure include wind speed, wind direction. In industry, we can be able to measure wind strength of different points regardless of their location on the map, or regardless of the time in the day. Here is a wind vane. A wind vane shows the direction of wind. The head shows the direction toward which the wind is moving from, and the tail shows the direction where wind is moving towards. Wind direction is where the wind is blowing from, but not vice versa. Wind blows to either north, east, south, or west. If wind comes from east, it is called an easterly wind. We can also use a windsock to know the wind direction, but they show the direction in which wind is blowing toward. Also used to measure the wind strength. Wind speed is measured by an instrument by the name anemometer. The faster the wind, the quickly the cap rotates, and vice versa. The faster wind is moving, the more damage it is likely to cause. We can justify that by looking at this little video. Look, the girl's book have been blown away by that strong wind. Again, here we can see this guy until he is unable to withstand the strength of the wind.
Welcome now to different types of winds. We have wind can be defined as air currents or moving mass of air from high pressure areas to low pressure areas. Typically, air under high pressures normally moves towards areas under low pressure. Thus, the greater the pressure difference, the faster the flow of air, which creates moving air with considerably strong force. The bulk movement of air occurs in the Earth's atmosphere and the outer space as well. There are total 5 types of winds. We have number 1, the planetary winds. The winds blowing throughout the year from one latitude to another in response to latitudinal difference in air pressure are called planetary or prevailing winds. They involve large areas of the globe. Second one is trade winds. These are extremely steady winds blowing from subtropical high pressure areas 30 degrees north and south towards the equatorial low pressure belt. These winds should have blown from the north to south in northern hemisphere and south to north in southern hemisphere, but they get deflected to the right in northern hemisphere and to the left in southern hemisphere due to Coriolis effect and Ferrel's law. Thus, they blow as northeastern trades in northern hemisphere and southeastern trades in southern hemisphere. Number 3 is the westerlies. These winds blow from subtropical high pressure belts towards subpolar low pressure belts. The westerlies of southern hemisphere are more stronger and constant in direction than northern hemisphere. These winds develop between 40 degrees and 65 degrees south latitudes, and these latitudes are known as roaring 40s, furious 50s, and shrieking 60s. Number 4, we have the periodic winds. Periodic winds change their direction periodically with the changing season, e.g. monsoon, land and sea breezes, mountain and valley breezes. Let's examine about monsoon winds. These winds are seasonal winds and refer to wind systems that have a pronounced seasonal reversal of direction. According to Flown, monsoon is a seasonal modification of general planetary wind system. summer monsoon is called southern westerly wind and is characterized by highly variable weather with frequent spells of droughts and heavy rains. The winter monsoon is a gentle drift of air in which winds blow from the northeast and is known as northeasterly wind. Let's examine about the land breeze. At night, land masses cool quicker than sea due to rapid radiation, which results in high pressure over land and low pressure over sea. And in calm, cloudless weather, air blows from land to sea. This breeze carries no moisture and is little warm and dry. Let's examine about sea breeze. In daytime, the land being hotter than the sea develops low air pressure, and the sea being cool develops high pressure. The air over land rises is replaced by a cool breeze known as sea breeze from the sea, carrying some moisture. Let's examine about mountain and valley breezes. A diurnal wind occurs in mountainous regions which are similar to land and sea breezes. During the day, the slopes of mountains are hot and air from valley flows up the slopes. This is known as valley breeze. After sunset, the pattern is reversed and cold air slides from mountain to valley and is called mountain breeze. Number 5, we have the local winds. The local difference in temperature and pressure causes local winds. It is of 4 types: hot, cold, convectional, and slope. We have important local winds. We have Chinook in USA. We have Fortune in the Alps, Switzerland. Then we have Salmon in Iran, Nor'wester in New Zealand, Birds in South Africa, Santana Anas in California, Sirocco in Sahara, Salana in southern Spain, Hamsia in Egypt, Simon in Arabia, Ghibli in Tunisia, Laventure in Sahara, Chile in Sahara, Brigvilda in Victoria, Australia, Zonda in Argentina, Armatan in Western Africa, Mistral in France, Bora in former Yugoslavia, Tramontana in northern Italy, Pampero in Argentina, Gregale in Sicily, Norda in Texas, USA, Norda in Mexico, Pangayo in Mexico, Lo in northern India and Pakistan.